Alright, this is additional example set number 4. Let's do number 1. Find the function values f of 0, f of 3, f of 4 for this given function. So let's write down the function 2x plus 1. So f of 0 takes the input 0 and applies the rule to that input number, so I get a 1. F of 3 takes 3 as the input, so it's 2 times 3 plus 1, which is 6 plus 1 is 7. F of negative 4 takes the input and puts it there, so I get negative 8 plus 1 is negative 7. For number 2, find the function values f of s, f of t plus 1, f of x plus 3 for this function. So my function is negative 7x plus 1. So now when I apply this rule to the input s, I simply put it wherever the input is. When I apply the rule to t plus 1, that's negative 7 times t plus 1 plus 1. And when I apply the rule to x plus 3 as the input, negative 7 times x plus 3 plus 1. For number 3, sketch the straight line given by y equals 4x minus 6. So number 3, y equals 4x minus 6. So this is the y equals mx plus b form that I have. So I know that if I take this negative 6, that is the y-intercept, so I know it goes through this point over here. The slope is 4, and I can see that as 4 over 1, which means that it's positive, so I know I'm going in this direction. For every change in y of 4, a change in x of 1 occurs. So if I go 4 up to negative 2, I go 1 to the right to 1, and there's another point that is on the line, and I get my straight line somewhat straight. It doesn't have to be perfect, like that. And now you can calculate the x-intercept. So let's say here x-intercept. I set y equal to 0. So I get 0 equals 4x minus 6. So x equals 6 over 4. Or you can simplify that fraction to 3 over 2 or 1.5 or whatever you want, and that sits right there. And there is the line corresponding to the equation y equals 4x minus 6. For the next one, number 4, sketch the straight line given by this equation. So let's write the equation down for number 4. 3x plus 5y minus 9 equals 0. So I need to get it in y equals mx plus b form, so I have to solve for y. So my first step is to get the y term alone on the left. So I can then say y is negative 3 over 5x plus 9 over 5. Now it doesn't matter, you can change these to decimals or whatever you want to do. It doesn't really matter at all. So this is the y-intercept. So let's mark it off there as 9/5. Now because this is a fraction, it's a little more difficult to interpret the slope. -3/5, yes. If I go 3 down, I go 5 to the right, but it's hard to do with fractions for me personally. So I can jump right to the x-intercept, where I set y equal to 0. I just need another point. I can have the x-intercept as that other point. So then I get -3/5x plus 9/5 equals 0. So I can multiply throughout by 5 to make this look a little nicer. So x is 9/3, x is 3, so I can put the other point over here somewhere. I don't really care about the scale or anything like that. Now it's a little bit more difficult to draw the line nice and straight. I'm going to turn the page just so it works with my hand a little nicer. Doesn't matter as long as you get something that looks reasonably straight. And there's your line that corresponds to 3x plus 5y minus 9 equals 0. For number 5, the supply Q for a certain suitcase with a retail price of $P changes according to the function P equals 0.5 Q plus 100. Interpret the slope of this function. If the price of a suitcase is increased by $5, how does the supply change? So let's write down the variables to remind me. In this case they do define it for me, so I don't have to worry too much. If they don't, then I have to define the variables first. P equals price, Q is quantity. Not P equals price, P represents the price. And they also give me the function relating the price and quantity. You can write it like this if you want, with the slope as a fraction. You can put it 0.5/1 really, but that helps me to interpret the slope, which is now change in price over change in quantity. This is my y variable, and this is my x variable. Change in x is change in y over change in x, change in p over change in q. So when I want to interpret the slope, I could say if the price increases by $1, then the quantity increases by 2 units. They're both positive, so an increase goes with an increase. Now they ask if the price of a suitcase is increased by $5, how does the supply change? Well, I can use the interpretation of the slope. Let's say C represents the change in the price. Now, an increase of $1 goes with an increase of 2 units. So a change of C dollars goes with if the price, if the price increases by $5, what is the change in the supply? So you see how easy it is to swap these around. I'm looking for the change in supply, which is a change in quantity. So you see, even regardless of how many times I do these things, I still have to read carefully and don't assume the question is asking one thing, but read the question carefully. So a change in $5 goes with a change in the quantity of C units. So I have my little ratio equation there, because the slope tells me how the changes go together. So I have C equals 2 times 5, C equals 10. C was just for me to set up my ratio equation, so a little concluding sentence. So the supply increases by 10 units if the price increases by $5. So as long as you read carefully, think carefully, just as I have to do still to this day, everything will be okay. In number 6, a delicatessen owner starts her business with debts of $100,000. After operating for 5 years, she has accumulated a profit of $40,000. Find the linear equation describing this information. So we are going to have to define some variables. Let's stick to x and y, why not? Let y represent the debt, or let's say the profit. Let's go with profit. Let y represent the profit after x years. So then they tell me that y equals mx plus b, straight line, linear equation. So now what do they give me? They give me pairs of values. They tell me that she starts her business with 100,000 in debt, so that's negative profit. And after 5 years, she has accumulated a profit of 40,000. Now, to make this more comparable, let's say the profit is represented by y in thousands. So then y, so this will be the profit, and y will be negative 140, just so the numbers are more comparable. So then my slope m, which remember is change in y over change in x, will be, let's choose this as point number 1, this is point number 2. Now we can say m, for the slope, is change in y, so it's 2 minus 1, 40 minus negative 100, over corresponding change in x, which is 5 minus 0, so I get 140 over 5. We can see if that simplifies. You can do it in your head, or I'll show you, the calculator is perfectly fine, and I get m equals 28. So I update my equation, y equals 28x plus b. What is this b? It's the y-intercept when x is 0. Y is negative 100. So that's b. So y equals 28x minus 100. In number 7, suppose a manufacturer of shoes will place on the market 50,000 when the price is $35 and 35,000 when the price is $30. Find the supply equation assuming that the price P and quantity Q are linearly related. So I'm looking for a straight line equation, and this is number 7. So let's remember that P is the price. And this time they don't say P is the price in thousands, so let's use the price as it is, and this Q is the quantity. So I know that P equals MQ plus B. And what else do they give me? They give me some numbers. When there are 50,000 units, the price is 35. And when there are 35,000 units, the price is 30. Let's call this number 1 and number 2, so that I can find the slope m, which is now change in my y variable, which is p, over change in my q variable, or my x variable, which is q. So it's going to be, p is at the top, so 30 minus 35 over q is at the bottom, so 35,000 minus 50,000. So you see the reason why I usually measure the price or the quantity or whatever in thousands, so the numbers are more comparable, so you get a nicer number for the slope. In this case I get negative 5 over negative 15,000, or you can write that as 1 over 3,000. And I'd leave it like that, not as a decimal. So I update, so P equals 1 over 3,000 Q plus B. Then we can use, it really doesn't matter which one you want to use 0.1, doesn't matter, whichever one looks nicer to you. Plug it in and get 35 equals 1 over 3,000 times 50,000 plus B, and that will give me the value of B. Let's calculate this first. 50,000 divided by 3,000. Oh, it's not a very pretty number. Not a very pretty number, so let's leave it as a fraction. 50,000 over 3,000. It's 50 over 3. So B equals 35 minus 50 over 3. So 35 minus 50 over 3 is 55 over 3. So P equals 1 over 3,000 Q plus 55 over 3. And you see the numbers are a little uglier because I didn't measure Q in thousands. But still, this is still my equation. There's nothing wrong with it. Let's check what they asked for. They just want the supply equation, so there it is. How do I interpret the slope? Well, it's change in P over change in Q, so if the price goes up by $1, if the price goes up by $1, then you supply 3,000 units more. Number 8, a house purchased for $245,000 is expected to double in value in 15 years. Find a linear equation that describes the house's value after t years. So they defined the t variable for me, but I have to say what the value variable is. Let's say V represents the value of the house after t years. Now what do they give me? Well, I have that it's a linear equation, so the y equals mx plus b form using my variables here, t and v values. So it's purchased for $245, so at t equals 0, that's the price. It doubles in 15 years, so then I have 490,000 for my house. So the B is given. The B is given at 245,000. It's just a matter of finding the slope, and in this case it's change in V over change in T. So this is now, let's call this point 1 and point 2. Change in V is 490,000 minus 245,000 over 15 minus 0. So M is 245,000 over 15. Let's see if that's a nice number. 245,000 divided by 15. Sadly, it is not really. So you can round it as a decimal, or I prefer to keep it as a fraction so that I can interpret the slope a little nicer. That simplifies to 49,000 over 3, but there's multiple ways you can do it. It doesn't matter. Or what was it? 16,333.33 repeating. Doesn't matter, it's all the same. Whichever one you prefer, to be honest. So V equals 49,000 over 3t plus 245,000. Do I interpret the slope? That's not what they're asking for. They just want the equation. There it is. If I wanted to interpret the slope, I can use this one and say that it increases in value by 49,000 every 3 years, or by 16,333 cents every year. And number 9, a certain store sold fancy witch hats for Halloween. At an average price of $5 per hat, the demand was estimated at 50 hats. If the prices increased to $9 per hat, the demand is estimated to decrease to 30 hats. Assuming a linear relationship between the price P of the hat and demand Q of hats, derive the demand equation expressing P as a function of Q. So number 9, they give me again P is the price, Q is the quantity of hats. So they're telling me it's a straight line, so I set it up like this. What else do they give me? They give me value pairs. At $5 per hat, my quantity is 50. At $9 per hat, my quantity is 30. So I call this point 1 and point 2. Slope is now change in P over change in Q. So P is 9 minus 5, Q is 30 minus 50. That is 4 over negative 20. Or I simplify that as negative 1 over 5. Update. P is negative 1 over 5 Q plus B. Use whichever point you're fancy. Maybe this first one. Plug it in and I get 5 equals negative 1 over 5 times 50 plus B. What is this? It's negative 10. So B equals 15. So my final equation is negative 1 over 5Q plus 15. That's all they wanted. Put a box around it and you're done. However, if you wanted to interpret the slope, you could say that, see, this is negative 1 over 5, which means that the price drops by $1 for every increase of 5 hats.